to solve linear systems. So this is in your notes, so just as a refresher, to find the inverse of A if A is the matrix A, B, C, D, we would do 1 over the absolute, or not the absolute value of A, 1 over the determinant of A times, we swap A and D, and then we change the sign of B and C to make them negative, or if they're negative, we make them positive. But again, you should have already had that in your notes, so that's just a quick refresher. And obviously that's given that if we multiply, the determinant's not 0. So, number 4, we have the matrix -2, 3, -3, 4, and we're finding the inverse. So, we would have 1 over, the determinant of this would be -8 minus a -9, so +9, times, swap the main, or this diagonal here, which we call our main diagonal, so 4, -2, and then we change the sign of the other numbers, so this top becomes -3, the bottom becomes +3. So then I have obviously just 1 over 1 here, so my inverse matrix is 4, -3, 3, -2. Now I can check to see if this is correct, so I'm going to just do one by hand to just, well, it'll refresh on our multiplication, but it'll also show you how to do it by hand. But normally I would just check them on the calculator when I check them. But we have -2, 3, -3, 4, and we multiply it by 4, -3, 3, -2. And if this works, the answer should produce 1, 0, 0, 1. So it should have 1s on the main diagonal going this way, and everything else should be a 0. So these are both 2 by 2s. So I take this top row times this first column. So -2 times 4 is -8. 3 times 3 is 9. So that goes there. Up here in this other one, top row, second column, -2 times -3 is +6. And then 3 times -2 is -6. Then second row, first column, -3 times 4 is -12, plus 4 times 3 is 12. And then second row, second column, -3 times -3 is +9. 4 times -2 is -8. And so then I get 1, 0, 0, 1. Yay. So that has just proved that I found the correct inverse matrix. Now again, I don't normally check these by hand, but I just felt like it was a good review of the multiplication. So we'll have a quiz at the end of this week on all of this stuff. All right, 6. -7, -9, 2, and 3. So I've got 1 over the determinant of this matrix. So how would I set up the determinant of this one?
1 over -21 plus 18.
Yep. And then we would, again, swap the main diagonal. So it'll be 3 and -7 swapping places. And then we change the signs of the other two values. So this will be a +9 and this will be a -2. So I've got -1/3 times 3, 9, -2, -7. So then I end up with -1, -3, +2/3, and then +7/3. And that would be your final answer right there. So the thing about an inverse matrix, a lot of times they do have fractions in them, so just be aware of that. Obviously our first one did not, but more often than not you're going to end up with some fractions in there unless things just happen to all cancel nicely, which sometimes happens, sometimes it doesn't. Do we feel like we're ready to try one on our own and see how we do?
Yeah.
All right, try this one. 6, -22, -12, and 20. I'll leave the other one up there for reference.
Calculator, where are you? What is it? 264. Minus. Okay. Oh. So give. That's really large fraction.
Just make sure you reduce it all the way.
So. Okay. 536, 1172, 112, 124.
They're all negative.
Negatives. Oh yeah, because it's negative. That helps. That's where I always mess up. I forget my signs.
All right, I'm going to go ahead and put it up. And then y'all can check and see how you did. So we had 1 over the determinant, which was 120 minus 264, times swap 6 and 20, and then change the sign on 22 and 12. Man down. So I got 1 over -144. My negative sign's so tiny. Times all of that. And so I wrote them all over 144. A lot of times but you're about to crush your backpack completely.
Oh, that would not be good.
So a lot of times I'll just go straight to reducing them. If you did, obviously that's fine. I was just showing what I did. So I took initially I took a 2 out of the 20 and 144, but then I needed to take another 2 out, so ultimately I took 4 out. And then I took 2 out of the second one, obviously 12 and 144. Hopefully you didn't need a calculator to do that one. And then 6 and 144, obviously that 6 went into 144, so I was able to reduce it that way. Anyways, questions on that one? Do we do okay? And again, obviously you can always check it on your calculator.
Systems of 2 equations.
Getting there, almost there. Now, if I told you to find the inverse of this, you probably have some fun with that one, right?
Yeah.
So, not that it can't be done by hand, but it's excessive, so we would do it with our calculator. I have done them by hand before, but I would never require y'all to do that. So we're going to put that matrix in matrix A. And what they're wanting us to do is they want us to find the inverse matrix, and then they want to confirm that it's an inverse by doing matrix A times the inverse of matrix A, and then the inverse of matrix A times matrix A.
Yeah.
Yeah, I'm lost after this.
What'd you say?
Ooh.
Yeah.
1 divided by
I'd rather not.
8.
Huh?
No, I'm slow. Ignore that.
Like you? Yeah, no.
Ooh.
Alright, so then call up that matrix that you have there. And then the button that you push to get to matrix is that little x to the negative 1. If you click that button, not with second, you'll see I have my matrix A, and then it shows a little negative 1. That means inverse. So to show on your paper that you've plugged it into your calculator, just write it like that. And then it's going to produce a matrix for you. Now, I do not like decimals in a matrix, so I'm going to show you how to fix it.
What do I click?
The x to the negative 1 button, that's the matrix button.
I don't have decimals.
You should click the matrix button without clicking the
Well, I
second
do,
button.
but like not crazy.
And then click
lines
equal.
Like that.
Enter.
Click enter.
Mm-hmm.
Oh, I have decimals.
Yours aren't the same numbers.
6,
It's just like negative one,
Don't
one,
say it first.
negative.
I wouldn't have noticed that.
I was reading the number.
It was no.
Did you type the numbers in right?
He
You
knew
said
what he
it.
was
You
doing.
said it loud.
I think so.
Proof?
1, 0, 2, 2, 3.
You're just gonna pay something to evidence.
Alright, so I don't like decimals in a matrix. So if you hit math, that's the button above matrix,
Ah.
Fraction.
then you'll see this. My teacher always called it dart frac, so that's always what I'm going to call it.
Cool.
But you hit that, and then you hit it again, and it puts it into fraction form for you, which simplifies it down. Now, that'll do that for anything, not just for a matrix. Anytime a decimal is produced for you, you can hit that, and it'll turn it into a fraction. And not that you can't just divide, obviously, 2 numbers, but some calculators get stuck and it'll only produce fractions for you. If right below the dart frac, there's a dart decimal button that will change it to a decimal.
Wait, what runs do you hit to get the fraction? Math.
Math. And then the frac 1.
Dude, should we bring up Brody to run fraction?
What in the
No, we just-
Jump Brody.
What if you just stop showing?
We asked Michael first if he asked him to show him this time.
Did y'all make a math instrument?
No,
He
He's
left
taking a
sick.
mental health day.
Oh yeah.
he does not need one.
He's probably still sick.
No comment.
No.
Oh, so that's the sign for if we're doing it on our calculator?
Yeah.
Is that all?
Oh, he was 820.
Now, the rest of this problem then said in the instructions to do A times A inverse Or wait, I wrote that wrong. Hold please.
A.
And to do A inverse times A. Okay, to show that it works, we're going to show that we get those ones on that main diagonal. But I'm going to show you something else just for your reference. Okay? Down here at the bottom, you see this button that says STO with the little arrow.
It works. It works. It's so cool.
This button right here means store. Okay, so it says take that previous answer and store that. Now, I'm going to tell it where I want it to store it. I'm going to store it in matrix B just for fun. Okay, we don't have to do this for this problem, but I'm just showing you because it's a fun thing you can do. So, I'm storing that. Then I'm going to hit second matrix, and then I'm going to store it in matrix B.
Oops.
So now, matrix B is the inverse matrix. Okay? So instead of me having to type A times, like matrix A times matrix A with the little -1 on it, I can just do matrix A times matrix B, and it will be the same thing. Now, I'm more just showing you that for reference. I would not ordinarily do that with this problem, but now I can do second matrix A times second matrix B.
Yeah, they never.
And it does it for you.
I think my calculator was wrong.
But I can also do second matrix A times second matrix A with the x to the negative, or the little -1 thing, and get the same thing. Okay? So either way you do it is fine. I just wanted to show you the thing with storing it because it's useful. But anytime you have something, so if you're in a science class and you're given a value, like in physics class, G is the acceleration due to gravity. So mine may not be in here right now. But a lot of times I tell them in G to store it. No, that's not it. That's a different constant. But anyways, a lot of times we will store a constant in your calculator, and you can do that just for reference on how to do that with your calculator. But anyways, I can also obviously do it the other way, and I still get 1 0 0 0 1 0 0 0 1. So if you did a 4x4 matrix, and you multiply it, you find the inverse and you multiply it by the original, you should still have ones on that main diagonal all the way down. Okay, that's what you're looking for to show that it's an inverse.
This pen says so.
All right. Last thing in this section, the moment you've all been waiting for,
Are you writing my
solving a system of equations using a matrix.
Oh, yeah.
We better do something. Come
All right, 36. Negative 3x plus y minus 8z equals 18. X minus 2y plus 7, or plus z, wow, equals negative 11. And 2x minus 2y plus 5z equals negative 17.
Johnny, you got that.
Yay!
All right, so up till today, you had no choice but to solve this by hand.
Calculator.
We're going to have this solved in probably less than 2 minutes with me even talking. So what we do is we take the numbers that are in front of here with their sign, and we put this in a 3x4 matrix.
Yes.
It's called an augmented matrix. Yep. So negative 3, 1, negative 8, 18, 1, negative 2, 1, negative 11, 2, negative 2, 5, negative 17. Now, normally we put a little ... here that will not show on your calculator. That's just for reference for you. This is my X column, Y column, Z column, and answer column.
This is so cool.
So what we're going to do is we're going to type that into our calculator, just like that.
And are we, what are we doing? Just make sure it's all on your system. That is so cool. What? What'd you say?
Wow, and like, no one.
Now, if you're looking at the book is not going to have you do it this way. They have you solving it with an inverse matrix. Way more complicated than what I'm about to show you. All right. There is a button that we're going to be using that is RREF. Okay? Now, if you hit second matrix and you go over to math, you're going to arrow down. Now, you have to be very careful. Option A is REF. That means something totally different than RREF. Okay? So you need this is row reduced echelon form. Now, your calculator does this process for you. In college, I had to do this by hand. It's awful. But your calculator does it for you in a matter of seconds. So, we're going to hit that. And then second matrix A or wherever you put it. Hit enter. And it's going to give you something that looks like this. Okay. So I get 1, 0, 0, negative 2, 0, 1, 0, 4, 0, 0, 1, negative 1. All right, so this means wherever the 1 is, that variable is equal to this number over here. So this means x is equal to negative 2, y is equal to 4, z is equal to negative 1. But I'm going to caution you, this is where people forget. Your answer still is an ordered triple. Negative 2, 4, negative 1. Your solution is going to be just the same as when it was in 3.4.
That's so much easier. I guess. That's great.
So, but what I'm going to tell you is, on your test, I can guarantee you are going to have to do a not 3 by 3.
3 by 4.
Solving 3 equation 3 unknown by hand, but it will allow you to check it. Okay?
Okay.
So, make sure you don't forget how to do that, but this is now a different way for you to check it. In worst case, you can't figure out where you went wrong doing it by hand. You can show that you did it checking it on the calculator and show, hey, I know this is what it's supposed to be, but I can't figure out where I went wrong. Okay? All right, let's do one more.
I can't wait to like use this.
21.
This is so
40.
So why are you laughing, bro? What is unfunny?
6x plus y plus 2z is equal to 11. X minus y plus z is equal to negative 5. And negative x plus 4y minus z equals 14. So let's do this on this one. See if you can set it up and
In our calculator or on the paper?
like the whole thing. See if you can work through and get the right final answer.
And then check it with our calculator.
No. All with the calculator. Sorry. Not by hand. All with the calculator.
Got it. Second matrix.
Oh, also you can quick do the RREF by doing alpha B or alpha abs,
Yeah.
which is nice.
You're so cool.
Shut up, Joey.
Yeah, Dylan.
Thank you. Wow, this took me like 5 seconds.
No. Forgot I did that. Oh yeah.
Shut up, Scott. You're good. Fancy calculator.
Wait.
Because it glows.
Okay.
I think I did it.
Wow. Why does yours glow? It's because it's a python?
Python.
Rough.
Does that make it different?
Second matrix.
You're asking
D.
me.
I mean, it's your cat.
Enter. No.
Congratulations.
Oh.
Should do it hard.
want to look it up still? Alright. I got you like that. You know you want it.
Interesting. Let's put a.
All right, so do we get an answer?
3, negative 5.
Why is this about?
Do we agree with her?
Yeah.
Yeah.
Agree with who?
Me.
What did you say?
3, negative 5.
Yeah, that's good.
All right, so make sure, okay, you need to show what I have written in blue. Okay, you need to show the augmented matrix where you've written it like this, okay, where you've just written the numbers, and that you're taking the RREF of that, and then to the solution of what your calculator gives you, and then ultimately to your final answer there.
I can't wait.
All right, any questions on that? Now, might blow your mind, but 2 equations and 2 unknowns also works the same way.
Perfect.
It would just be
1
2
row
by
left.
1 less, yeah. Yeah. So like if we had,
Wowzers.
Oh.
I'm just going to backtrack for a second to 32 and show you.
Googly moo.
2x plus y equals negative 2, and 2x plus 5y equals 38. I would then have 2, 1, negative 2, 2, 5, 38. And then I would RREF that. And when I do that, let me go put it in. Whoops.
Ow.
That's what you get. Because you stink.
What's wrong with me?
So then this one would give me 1, 0, negative 6, 0, 1, 10. So x is equal to negative 6, y is equal to 10. So negative 6, 10 would be the solution to this one. So you could solve 4 equations and 4 unknowns. Same way. But anyways, just so that you've seen it, that's a way you can check your work.
And your calculator died.
Huh?
Oh, it died. Did it die or did you just turn it off?
Stop looking at me.
No, it's still on. I just turned the light off.
Oh, that's a lie.
No, this has a light.
Oh, I'm trying not to
Did
laugh.
you not see when she first put it up there that it was like
No.
just black?
No.
All right. Problems.
I don't want to hear your yap.
I found out when I closed my eyes.
Well, you're gonna hear that.
5, 7, 9, 19, 35, and 39.
Give me all your paper. Brody has a lot of paper.
He never likes
These last 3 can be done on a calculator. Well, I would strongly advise them being done on a calculator.